Hello my dear students, in this lecture we are going to see on previous year GATE numerical. This numerical was asked in GATE 2019 for 2 marks. The question is, a short shoe external drum brake is shown in figure. See here, diagram is given for short shoe external drum brake. The diameter of the drum is 500 mm. Here, diameter of drum is 500 mm. Therefore, radius of drum will be 250 mm. Then, for this drum, here for this drum, diameter is 500 mm. Therefore, radius will be 250 mm. Again, the dimensions A is equal to 1000 mm. See, the dimension of the distance of force F from the hinge O is A, which is nothing but A is equal to 1000 mm is given. After that, B is equal to 500 mm. B is nothing but, here at contacting surface there will be a normal reaction. From this normal reaction, B is at, means this hinge will be at B distance, which is 500 mm. B is equal to 500 mm and C is 200 mm. In data it is given C is equal to 200 mm. See here, C is 200 mm. Now at this contacting surface there will be a frictional force also, and from this frictional force the hinge is at distance C, which is nothing but 200 mm. The coefficient of friction between the drum and shoe is 0.35. Here coefficient of friction mu is given 0.35. After that, the force applied on the lever F is 100 Newton. This force F is 100 Newton. Right, F is equal to 100 Newton. As shown in figure, the drum is rotating anti-clockwise. See, the drum is rotating in anti-clockwise. The braking torque on the drum in Newton meter is. Now, the question is to find braking torque in Newton meter. We have to find it in Newton meter. Right. Now, let us solve this question. My dear students, whenever there is a contacting surface between this brake shoe and drum, here it is a drum, this is a drum of diameter 500 mm. Between this drum and brake shoe there is a contact here. At this contacting surface there is always normal reaction perpendicular to the contacting surface, right? And there is a frictional force parallel to the contacting surface like this, and this frictional force is acting as a tangential force on the drum. Now let us solve this. If I consider free body diagram, right, on this drum, see, first of all, normal reaction is definitely on this drum, normal reaction definitely acting in downward direction, right? And see the contacting point, right here, the normal reaction will be on drum. The normal reaction will be like this, downward direction, right? Now, the contacting point, this contacting point, can you imagine, because of anti-clockwise rotation, the contacting point will move towards left like this, anti-clockwise rotation. This contacting point will move towards left. Therefore, friction is opposite to the motion. Therefore, there will be a frictional force which will be opposite to the motion. Right, on drum, it is on drum, which is nothing but Fr is equal to mu n. Right. Therefore, we have identified the direction of normal reaction and frictional force on drum. Here I am erasing this drum and I will draw at other location this drum diagram. Right. Now here let us say we will get space. I will erase the question. Right. Now for this drum, if I see drum, we have identified the directions of friction force and normal reaction. Let us say this is a drum. On this drum, normal reaction is acting in vertically downward direction like this, and frictional force is towards right. That is Fr is equal to mu n. Right. Therefore, for these actions on the drum, there are reactions on the brake shoe. As per Newton's third law, for action there is equal and opposite reaction. Therefore, for these two actions, these two are the actions of surface. Right. Normal reaction is a surface force, friction is the surface force. There will be equal and opposite reaction. Therefore, on brake drum, on brake shoe, the normal reaction will be vertically upward like this. There will be a normal reaction, and at this contacting surface, the frictional force will be up towards left. The frictional force will go towards left like this. Action reaction pair or not, that is mu n, that is mu n, right? Now, and here the radius of brake drum is r, radius of brake drum is r. Now our target is to find torque applied on the brake drum. Can I say torque applied on the brake drum is this tangential force, that is frictional force, into radius. Therefore, to find torque on the brake drum, we have to find frictional force because radius is known. Let us solve for frictional force. Now look at the diagram of lever. Look at the diagram of lever, this diagram, right? If I see this diagram, this force ef is at distance a from the pivot, right? And o is pivot. At o you can say it is a pivoted, right? Therefore, for equilibrium of lever, for equilibrium of lever, we can say summation of moment about pivot must be equal to 0. That means summation of moment about O point must be equal to 0. Now let us consider moment about O. Now while considering moments, clockwise moments are considered positive, anti-clockwise moments are considered negative. Now about this O, this applied force is creating anti-clockwise moment like this, right? Therefore it is negative. Therefore we can say minus EF at distance A. This force is at distance A. Now this again mu n about this O, this mu n is also creating anti-clockwise moment. Therefore, there will be minus mu n at distance C. It is at distance C or not from pivot, right? Again, this normal reaction is creating clockwise moment. Normal reaction is creating clockwise moment, therefore positive, and normal reaction is at distance B. Therefore, plus n into B is equal to 0. Now put the values. F is given 100 minus 100 into A. Distance A is given 1000 minus coefficient of friction is 0.35, right? Normal reaction is unknown, into C is given 200 plus normal reaction is unknown, B is given here, B distance is given 500 is equal to 0. And my dear students, in this total equation only normal reaction is unknown. If you see at the equation, only normal reaction is unknown. Therefore solve for normal reaction, and then you will get normal reaction is equal to 232.558 Newton. This normal reaction value you will find, right? Now what is braking torque? Braking torque is nothing but a frictional force into radius. Therefore, braking torque is equal to frictional force into radius, which is nothing but mu n. Frictional force is mu n, that is mu times normal reaction into radius, right? Therefore, put the values. Therefore, mu is 0.35, normal reaction is 232.558 into radius. We have seen radius is 250. Radius is 250. Therefore, braking torque is equal to 20.35 into 10 to the power 3. And my dear students, dimensions we have used in mm. Therefore, this braking torque will be in Newton mm. But my dear students, they are asking in Newton meter. They are asking braking torque in Newton meter. See, if you look at the question is to find braking torque in Newton meter, right? Therefore, convert this braking torque into Newton meter. If you write this answer, you will get 0 marks. Therefore, braking torque is equal to 20.35 Newton meter, right? And this is your answer. And as it is fill in the blank question, in a bracket, in this space provided, you have to only type 20.35 because already in it is mentioned. Thank you dear students. In next lecture we will start new topic.